Okay, so I'm going to start working on the encoder now. So we'll have a CodeGen package with x86 in it, and we'll start with an encoder type. The encoder is just going to be a struct that holds the byte slice that's currently been emitted. So we'll also have a function on encoder called emit. And this will basically take some kind of op to emit. So we'll have type op int, and this can basically represent things. So for example, op unknown is going to be an op equals iota. Then we'll have, for example, maybe starting with some very simple operations to encode, like syscall and RET. And then within the emit, we'll just append bytes for the operation that needs to be encoded. So we should probably set up some tests as well. And the way that I thought I would do these tests, testing.t, is to have NASM output some listing files that I then process to generate like expectations for things to emit. So for example, if we have a test table, which will be a struct, we'll have a listing file for each group of cases. So this will be a listing file. And then each listing file will basically have a bunch of cases to test. So the case will be the arguments that I'll pass into my emit function. So right now that's just an op. And then we'll basically just loop over all of these. So this will be like a group of tests. So test group in the test table. And then what I want to do is read a listing file from NASM and process that to build up the expectations. So if I have a test data folder here, and these are simple instructions, so I'll just call it simple.asm. 64-bit is what I care about right now, and we'll do syscall and RET. So for example, with NASM, we can do, let's say, test data, CodeGen x86 test data, simple.asm, and then if we use the L flag, we can output a listing file, which we'll call simple.lst. So if we look at this LST file, we see that we get the line number of the file, we get the offset into the machine code, we get a string representation of the machine code as hex, and then we get the lines that I actually wrote in the file itself. So the idea will be that for each of these lines, we'll create a test expectation and then use the cases to emit bytes and test against the expectation. So one of the things I need to do is process this file, but there's a couple of things to keep in mind about NASM listing files. One is that it will keep things like comments, so this is a comment, and if the hex representation of the machine code here is a fixed column width, so if that goes above a certain number of bytes, then it goes onto the next line, which is indicated by a hyphen. So for example, if we do mov to rex with some 64-bit immediate and regenerate that listing file, now we can see, for example, that this one was too long, and so there's a hyphen here, which means that it's continued on to the next line. And this comment is here too, and we've also got this directive. So we want to ignore a couple of these lines and concatenate a couple of these lines together to generate correct test cases. So for example, in this case, the test table, we can say that the listing will be simple.lst, and this will contain a slice of cases. where each case is currently just an operation. So for example, the first test case would be op syscall, and the second case would be op RET. And then for each of these test groups, we want to read in the listing file described by the listing field. So we'll have bytes and error of OS read file. This will be test data / tg.listing. If there was an error, then we'll just fatal with the error. And then at this point, we've got the listing file. So if I just do something like t.error and error with string b, just to see if it's reading it correctly. Okay, so we get the contents of the file here. So I'd want to go over this line by line. So for example, if I do line in range strings.split sequence and split by the new line, then t.error line, that should still give me each line individually. And then I want to split it into fields. So we'll have fields is strings.fields, and then t.error for fields. So I want to skip any fields which are not at least 4 in length. So that would skip these 2 top ones. This is a comment would still be included. And this one will be skipped as like because it's not really the start of a new test case as well. And then finally, this last line will also be skipped. So for example, we'll say if length of fields is less than 4, then I'll just continue. So we still get the comment, but we get the other ones. So I need to concatenate this with the next line. So I suppose if, to start with, I just break these out into variables. So I want fields 0 for the line number. The code itself is index 2, because I don't care about the offset into the machine code. And then the assembly is index 3 onwards, which I'll just join into a string with a space. So this is line num code and assembly. Then I need to figure out how to concatenate this. So I think if I need to see if code on the next iteration of the loop ended with a hyphen. So I'll actually need to move these variables outside the loop. And rather than redeclaring them, I just want to define them down here. So if strings.has suffix code hyphen, then I would want to continue. Or not continue, I would want to concatenate onto the existing code, but remove the hyphen. So code would actually equal strings.trim suffix code hyphen, and then we'd add on the fields too. But then even if this is the case, I don't want to skip the line. So this should probably be a switch, really. So we'll say switch. We'll change these two into cases. And in the default case is where I'd want to redefine, because that's where it would be like starting a new test. So down here, if strings.has suffix code hyphen, if it still has a hyphen at this point, we'll continue. Okay, so that should give me the concatenated instruction. So this is the full machine code represented as a string of hex now. So I still need to skip this comment one, and part of the sort of expectations I want to build up is that the encoder holds a byte slice of encoded instructions so far. So to compare that, I want to convert this hex string into a byte slice as well. If I try and convert it and we get an error, then I'll just continue. So that would skip over this comment naturally anyway. So we'll say b error is hex.decode string. Well, we'll decode the code, and if there was an error, we will just continue. Let's put the bytes on the end. Okay, so now we skip over the comment, but we get the bytes for the hex representation of the code. So at this point, I can start building up expectations, which I'll just call a want. So we basically say that we want certain code, which will be a byte slice. We'll keep track of the line number for error messages and the assembly for error messages as well. And then we'll just build up the wants, which will be a slice of want. So down here, instead of doing the error now, we can just append a want, which will be line is line num, code is b, and ASM is just ASM. So the expectations and the cases that I want to test should be equal to each other. So if the length of the tg.cases does not equal the length of the wants, then we'll just fatal with a mismatch between test group case length, test group cases and expectations. Otherwise, we can basically just loop over all of the cases and test them against the expectations. So we'll just say for test case range over tg.cases. Then we need the expectation, which will be wants sub I. So I need the index here. Then I need to do a comparison. So we'll say that if the bytes do not equal between the tc.code and the want.code. In this case, we'll do an error. And actually, before I do that, I need to get it to emit something. So we'll need an encoder where we can call emit, where tc gets the OP passed in, and actually this tc.code will be encoder.code. So we pass in the arguments to the encoder. So I'll need an encoder up here as well. Encoder. And if the encoder bytes do not equal the expectation bytes, then we'll do an error. So we'll just go on to the next line. We'll say maybe print out the assembly first with the line that it's on. Then we'll pass out what we actually want to get, which will be some hex string. And then we'll pass out what we actually got, which will be this hex string. So we'll say want.asm, want.line, want.code, and enc.code. Then before the next loop comes around, we'll just clear out the code that was stored in the encoder so that it can compare clean on each loop. So if I run these tests now, we get a mismatch between test group cases and expectations. That's probably because I left the mov in there. I won't do that one right now. So we'll just regenerate that listing. Okay, so now we get syscall line 4, we want this, got nothing. RET line 5, want this, got nothing. I'm just going to indent the assembly a little bit so that it's in line with the machine code there. So syscall is the secondary opcode map with the 05 opcode, and then RET is just the primary opcode map with C3. So if I just implement these in a very simple way, just using a switch on the op. So if it's op syscall, then e.code equals append e.code secondary opcode map followed by the actual opcode bytes. And then the RET is just the primary map with C3. Okay, that passes. So I think that makes me ready to start testing some decent encoding now.